Here we shall see about the next type of combinations of resistor. The second type of combinations of resistor is the combinations of resistor in parallel. So parallel combinations of resistor mean that the first end of each resistors are connected to one single point A, and the second end of all resistors are connected to another point B. So when you joined the resistor in this way, then this type of combination is known as the parallel combinations of resistor. We have seen in the previous video about the combinations of resistor in series. So in series combination, the physical quantity that is remaining constant, it is the current I, which means the current through each resistor is the same. But here the physical quantity which is remaining constant, it is the potential difference across each resistors. So the potential difference across each resistors, it is the same as the applied potential difference V. Alright, okay. So these two free ends A and B are connected to a potential difference V. Now this potential difference V will send out a current I to the circuit. Alright, and this current I, it is coming from the cell, from the positive terminal of the cell. It goes like this and it reaches point A. At this point A, this current I, it is split up into three parts. Current I1 will be flowing through R1, current I2 will be going through R2, and the current I3 will be going through R3. Alright, so I can say that this total current I, it is nothing but the sum of all the currents in the different branches. Alright, okay. Now from Ohm's law, we have V is equals to I upon R. If you find out I, you will get V upon R. So this is actually the equations for the current from Ohm's law. So applying Ohm's law for the current I1, you will get potential across resistance R1 upon resistance, that is R1. Similarly, I2 will be the potential across R2 and the resistance R2. For I3, it is V upon R3. Next, I will take common V and I will have inside bracket only 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay, or V taking or I taking V to this side, then you will get 1 upon R1 in the on the right hand side plus 1 upon R2 plus 1 upon R3. Now what is this I and what is V? I, it is the total current which is sending by the cell, and V, it is the potential difference of the cells. So I upon V, okay, so when you find out I upon V, okay, from here this is equals to how much? I upon V mean 1 upon R. So therefore this I upon V, it is nothing but it is equals to 1 upon R. So this is total current upon total potential difference. So therefore you will get a total, when you substitute this I upon V, you will get a total total resistance which can be written in the form like 1 upon Rp. So this subscript P stands for parallel. So therefore 1 upon Rp, it is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay, okay. So you can name this as your equation 1. So from this equation 1, we conclude that the reciprocal of the total resistance is equals to the sum of the reciprocals of the individual resistances. Okay, so this equation 1 can be extended to any number of resistor. When you have n resistors connected in parallel, then the total resistance, it can be written as 1 upon Rp is equals to 1 upon R1 plus 1 upon R2 plus plus 1 upon Rn. Okay, so here we have considered n resistors connected in parallel, so their total resistance will be given like this. Okay, all right. So this is all about the combinations of resistors in parallel. All right. Okay. So a point to be noted, right, in this case is the first point is, that the potential differences across each resistor is the same. That is the first point. The second point here, where you have I is equals to V upon R1, this I1 is equals to V upon R1, which means this I here, when you say I1 is equals to V upon R1, I2 is equals to V upon R2, what does it mean? I3 is equals to V upon R3. It means that the current through each resistor, it is inversely proportional to the resistance. Alright? Because why? This V across each resistor is same. That is the second point. Okay. The third point is the total resistance of the circuit. When you combine R1, R2, R3, you should get just one resistance. But the total resistance of the circuit here, it is smaller than the smallest resistance of the given resistors. Okay, for that it means if I consider R1 is equals to 1 ohm, R2 is equals to 2 ohms, R3 is equals to 3 ohms. So when you find out the total resistance, that is 1 upon Rp is equals to 1 upon 1 plus 1 upon 2 plus 1 upon 3. Find out the LCM between 2 and 3 will be 6. So 1 times, okay, 1 times how much to get 6? 1 times 6. So 6 times 1 will be 6. Plus 2 times 3. 3 times 1 means 3. 3 times 2 is equals to 6. 2 times 1 will be 2. So 1 upon Rp is equals to 6 plus 3 mean 9. 9 plus 2 mean 11 upon 6. If you convert, or if you're taking the reciprocals of 1 upon Rp, you'll get Rp up and 1 down. 11 upon 6, you'll get 6 upon 11. So now dividing this 6 by 11, you'll get how much? 11 0 is 0, remaining 6. Put a point, bring down 1 0. 11 5 is 55, remaining 5. So on, this process will continue. So which means this Rp, it is equals to 0.5 ohms. So what does it mean? It means that this resistance Rp, which is 0.5 ohm, comparing to 3 resistors R1, R2, R3, you find that this 0.5 ohms, it is smaller than this R1, because R1 is the smallest among 3 resistors. So the total resistance in the given circuit, it is smaller than the smallest resistance of the given circuit. Alright, so these are the points which is very important regarding the combinations of resistor in parallel. Okay, so please note down here that in exams, if a question asks you to derive about the total resistance of the resistor connected either in series or parallel, so please remember that you should draw a circuit diagram. If you don't draw a circuit diagram, then you will not get a full marks. Okay, because I have seen while doing the correction, many students, they just do the derivation without showing the circuit diagram. So if they are doing it that way, then we cannot give a if the question it is 3 marks, let's say it is 3 marks, then I can give 3 marks though the derivation is correct, because without circuit diagram, how do you consider this, how do you get this I1, how do you get this I2? Okay, I don't understand all these. So therefore please remember that circuit diagram is always necessary for you to draw during exam time when the question asks you about the derivation. Not just only this topic, but in every topic, for especially during the for the derivation, you have to always draw the circuit diagram. Okay, so with these things, then we will stop about this video here.